We are planning to design the PCB of the AVR8NG32 microcontroller input and output configuration project. Recommended, watch its video. To complete the example, let's add a new section to the project. We want to display port D information on 8 LEDs. We use an octave dip switch to change the logic of the port D. We use 8 resistors with 220 ohms value. The correct way to drive the LED in the video as discussed by configuring the input and output of the AVR8NG32 microcontroller. We use from labeling, to connect port C to the resistors. If you are not familiar with how to use the property assignment tool, watch the video of the property assignment tool. In the code vision, we define port D as input, and enable pull-up resistance. And define port C as the output. The correct way to configure the AVR input and output is discussed in the video of the AVR8NG32 microcontroller input and output configuration. Compile the file, and program the AVR. This part is related to the previous one. New part. Now, let's design the PCB of this project. First, I review the package of components. The resistance package is suitable. The key has no package at all. Capacitor package is suitable. No package specified for the LED. The AVR has a package. Dip switch does not have a package. Let's start with the LEDs. It is recommended to watch the video of the PCB of the common emitter amplifier. Search for LED in the packages library. It looks like a good package. To attribute the package to all LEDs, we use from the property assignment tool. Let's hide the package name. Check some LEDs randomly. Find a package for the push button. The SW push 1 package is well. For the push button, to define the package, we edit this component and save it in the library with a new name. Select the component and decompose it. You can use from, edit all properties as text. Apply these changes. Highlight the component again and select Make Device. Select the component name button 1. Accept other defaults. At this stage the package can be defined. Check the package and define the pins. If the pins are assigned correctly, they will change color to white. Check the package. Create a category called User, and save the new component in it. Delete the previous component, and select the new component from the library. Replace the new push button. Package for dip switch. This component has two models, the model that is simulated, but does not have a package. Another model that has a package but cannot be simulated. In the case of a dip switch, let us use the equivalent component. Let's use this model and choose another suitable package for it. To match the pins, preferably edit the component as before. And save it with a new name. The SWDIP8 package is well. Pay attention to their names and numbers to match the pins. Name the component SWDIP8_1. Follow the instructions as before. Replace the power supply with a connector. Note that this name appears in PCB. To place the package, display the specifications of some components. We are now ready to design a PCB. Because the packages are complete, the benefits of Netlist can be used for PCB design. The first step is to choose a board. To properly place the packages, let's use from AutoPlacer and manual adjustment step by step. First, the microcontroller, dip switch and connector. This arrangement is appropriate. Two push button with their capacitors and pull up resistor of reset. Use manual adjustment. Now bring LEDs 1 and 2 as a guide. Move them to the right so that they can be used as a guide in the next step for AutoPlacer. Select the other LEDs. Arrange the location of the LEDs, approximately. At this stage, bring the resistors. Now adjust them carefully. For the 8 LEDs on port C, first place 2 LEDs as a guide. Select the other LEDs. In the last step, we select all the packages. We plan to use from AutoRouter, but before that do the latest editing. We set rules for the router. All connections should be at the bottom of the board, and the size of the power. Connections should be T30. The circuit is not complicated, we have no problem. Let's make some changes on the component side. These changes have no effect on other layers. Get a report of the whole project. Thanks for watching. If you are interested in the topics of this channel, do not forget to subscribe.